In today's video, we're going to be going over how to calculate the derivative of a function by definition. So if this is something you struggle with, keep watching. So as a refresher, if we wanted to find the derivative of a function, one of the ways that we can calculate the derivative is using the definition, which states that f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So today we're going to be actually going over how to calculate the derivative of this function, which is f of x equal to x cubed minus 3x plus 5. So this definition, as you see, is a handful. So what we're going to be doing is breaking it up into manageable chunks. So the first step that we're going to be doing is we're going to be calculating f of x plus h. So to find f of x plus h, we are going to plug in x plus h into x. So when we do that, that will give us x plus h cubed minus 3 times x plus h plus 5. Now the catch is that we have to fully expand this, meaning that we have to fully multiply out x plus h cubed, which can be a pain. So you could multiply x plus h 3 times by foiling x plus h and then taking that result and multiplying x plus h to that. But I highly recommend refreshing your knowledge on binomial theorem because that will come in clutch when you're expanding binomials such as x plus h cubed. So what we're going to be actually doing is going over the formula to use to expand x plus h cubed, which is from the binomial theorem formula. So if we wanted to expand x plus h cubed, basically we can use this formula which states if we have a binomial in the form of a plus b cubed, that expands to a cubed plus 3 times a squared times b plus 3 times a times b squared plus b cubed. So in this case, our a is the x and the h is the b. So we're going to plug in x and h into the a and b. And when we do that, that'll leave us with x cubed plus 3 times x squared times h plus 3 times x times h squared plus h cubed. And basically, that's going to be the final result. As you see, there's no like terms, so we can't really combine it. So that's just the final answer when we expand it. So we will rewrite x plus h cubed to become that. And the next thing we can do is we can also distribute this negative 3 to the x plus h. So when we do that, that will give us negative 3x minus 3 times h plus 5, because we'll bring down that 5. So we'll be left with x cubed plus 3 times x squared times h plus 3 times x times h squared plus h cubed minus 3x minus 3h plus 5. And that's the final result. And unfortunately, we can't really further simplify this because all these terms are not alike. There's nothing like about this. So we're going to leave this as is. So the next step that we're going to do is we're going to find f of x plus h minus f of x. So essentially what we're going to do is take what we found previously and now subtract f of x from it. So to do that, we're going to take our previous answer, which is f of x plus h, and we're going to subtract f of x, which is x cubed minus 3x plus 5. And when you subtract f of x, I recommend surrounding the function in parentheses, because when you're subtracting, oftentimes we can get the signs confused. So to eliminate that confusion, we can surround the whole function in parentheses. Now, once we do that, what we're going to do is first get rid of this like minus sign. Like we're going to distribute this minus sign to the x cubed minus 3x plus 5. That way we can have a true sense of what the signs are of our terms. So when we do that, we'll distribute this negative to the x cubed minus 3x plus 5, which will leave us with negative x cubed. And then negative times a negative 3x will give us a plus 3x. And then negative times a 5 will give us a minus 5. So now we can actually see like these are the actual signs of our terms. So the next thing we're going to do is we're going to actually combine like terms. So there's a lot of terms that we're dealing with, so we're just going to work from the front and go work our way down. So we have x cubed as our first term, right? So let's find any other terms of x cubed, which we have here. We have a negative x cubed. So when we combine those, x cubed minus x cubed will actually cancel out, so we can eliminate those. Now the next term is we have 3x squared times h. There's no other terms with 3x squared times h, so we'll kind of skip that. Next, we have 3x times h squared. Once again, we don't have any other terms with like x and h squared, so we'll skip that. And then we have h cubed, which is next, which once again, we don't have any terms with h cubed, so we'll skip that. But if we look at our next term, we have negative 3x, and we actually have another term with x, which is this positive 3x. So if we do negative 3x plus 3x, that will actually cancel out, and we'll eliminate those x's basically. Now if we look at the next term, we have negative 3 times h. Once again, there's no other terms with h, so we'll skip that. And then lastly, we have a 5. So we have a 5 here, and then the only number we have in this is the negative 5. So once again, we have 5 minus 5, which will cancel out. So when we clean this up, we'll be left with 3 times x squared times h plus 3 times x times h squared plus h cubed minus 3 times h. Okay, so next step is we are going to take this result that we got, and we're now going to divide that all by h, okay? So when we do that, we'll be left with 3 times x squared times h plus 3 times x times h squared plus h cubed minus 3 times h all over h. So we're essentially now calculating f of x plus h minus f of x all over h, okay? Now, if we were to leave this as is, right, remember we are calculating the limit as h approaches 0. Remember with limits, we have to plug in the value that, in this case, h is approaching. Now, if we were to plug it in as is, well, h is in the denominator, so if we plug in 0 in the denominator, that will give us an undefined value, which we can't have. So what we want to do in this step is to eliminate the h in the denominator. So to do that, typically what you're going to have to do is factor out the numerator, okay? So if you look at our numerator, we have 3 times x squared times h plus 3x times h squared plus h cubed minus 3 times h. Notice that they all have at least one h in common, which means that we can actually factor out that h. So what we're going to do is factor out an h from the numerator, and that'll leave us with h times 3x squared plus 3x times h plus h squared minus 3. And now that we factored out that h, we now have an h in our numerator and denominator, which means we can cancel those out. So f of x plus h minus f of x all over h will clean up to become 3x squared plus 3x times h plus h squared minus 3. Now the next step is to now find the limit as h approaches 0 of f of x plus h minus f of x all over h. So we're just going to take what we found previously, and now we're going to find the limit as h approaches 0 of that result. So basically now we're going to calculate the limit as h approaches 0 of 3x squared plus 3x times h plus h squared minus 3. Now remember, when you are finding the limit, you just want to plug in the value that, in this case, h is approaching. So we're going to plug in 0 into h, and when we do that, that'll leave us with 3x squared plus 3x times 0 plus 0 squared minus 3. And when we simplify that, well, 3x squared plus 3x times 0, well, 3x times 0 is 0, and then 0 squared is 0. So that'll simplify to give us 3x squared minus 3. So we get that the limit as h approaches 0 of f of x plus h minus f of x all over h is equal to 3x squared minus 3. And actually, now that we've evaluated our limit, this tells us what f prime of x is. So for our final answer for the derivative, we can say that f prime of x of this function is 3x squared minus 3. And that's it. So as you see, this was tedious. And it's not necessarily that it's hard, it's just a lot of steps, and it really requires you to have a strong foundation on your algebra, because as you see, there is factoring and combining like terms, all that jazz, right? So it's just very tedious, and a lot of us are not fond of calculating the derivative by definition, but it's just something that's necessary to understand. So I hope you found this video helpful, guys, and take care.